Good evening, everyone. I'm Kandy Rathinasamy, Product Manager for Healthcare Analytics at InterSystems. I have with me Sofia, who's a developer on my team. We work on Health Insight. So today we're going to talk about improving query performance. As you've probably been hearing at the conference, Iris can be very powerful, can do a lot of things. You can throw all kinds of data at it. But getting it to perform at scale, takes some understanding and knowledge. So that's what we'll talk about today. We'll give you some information that will help you make your healthcare queries run faster, run better. So here's what we're going to be talking about. For those that are not familiar with our product, I'll give you a very quick introduction to what it is. We'll talk about patterns of use that we see in healthcare and to some extent how they differ from other industries. And then we'll dig into the meat of it, which is going to be, we'll give you some good information about how best to optimize queries and have them perform well at scale. I'll talk a little bit about what we've done in our most recent release, and then Sofia will talk about additional things you can do to really rev up the performance of Health Insight. So let's dig in. Health Insight, for those of you who are not familiar with our product, is InterSystems healthcare analytics product. It works with healthcare's HealthShare unified care record, brings in all the data that's in there, clinical data from EHRs, claims data, pharmacy data, SDOH data, and presents it to you in an analytics data model that analysts can use, that you can use from Power BI, things like that, make use for AI, all of that. Okay, we're going to talk about guidelines that will help you improve your performance, and this is based on working with many customers at scale, and our own testing to push the performance of Health Insight and the underlying platform, Iris. However, your use cases, your data might look a little bit different. So, as they say, results may vary. Your results may vary, but overall, we'll give you some guidelines that will really give you a boost to your query performance. So before I dig in further, there's two broad patterns that you can use with analytics with Health Insight. So if your data tends to be, and the analytics that you want to do, tends to be of the multidimensional analysis variety, where you've got pivot tables, you've got various dimensions, you want to slice and dice and see patterns that way. That is a pattern that we support. That is not, however, what this talk is going to be about. I'm going to talk about the other pattern, which is using SQL queries directly on the data. You can use both. You can use either, whatever works for you. So healthcare. Why is healthcare somewhat different when it comes to queries and query performance? Well, a lot of data in healthcare has codes, as many of you probably know. There's diagnosis codes, lab results have codes, medications have codes. So you need to kind of know how to use codes and kind of how to speak that language, and we'll talk a little bit about that. You're very often looking at date ranges, the data that's from several years ago may not be relevant, or you might be interested in a very specific period because that's when, for example, HEDIS measures based on a calendar year, that's what you're interested in. So you're typically interested in date ranges, and we'll talk about optimizing for that. And then there's patient demographics. You're often sort of looking at things by geographic location, by where the patient lives, or their race, their gender, things of that nature. So we'll talk about that as well. Let's dig in. Okay, the first rule would be index, index, index. So you need to index your data before your queries are going to give you the performance that you're going to want to see. So sometimes we get the question, well, why don't you just index everything? Well, there is a cost, so there is a bit of a trade-off. You want to make sure you index anything that you're querying on. So anything that's in a where clause in a SQL query, you want to make sure there's an index for that. The other side of that, this is the cost side of it, is if you're not going to query it, you can still access the data, but it's not in a where clause, you don't need to index that. And that will, if by not indexing some elements in Health Insight, we're making our ingestion performance faster. So loading the data will be faster, and you're not incurring the storage cost that the index incurs. So there's a little bit of a trade-off there. You do want to make sure you have indices, though. That's the big takeaway. The next one I'd want to point to is to use bitmap indices. These are indices that are really built for analytics in a lot of ways. So if your data does not have a lot of unique values, so it's not high cardinality data, if it's gender or a binary value, true or false, those types of things, up to about 20,000 distinct values, a bitmap index will work really, really well. So if your data is such that you expect the values to be within that lower cardinality range, you really want to use a bitmap index. And bitmap indices will work across multiple columns very nicely also. So if you have a where clause that says this column is within this range and that column needs to be this value, a bitmap index will handle that very nicely. You don't need to do anything more. So bitmap indices are very nice if, however, you can get your data, the unique values in a column down to under about 20,000 distinct values. So what if you can't do that? Well, we have other indices. There are regular indices, of course. You should use those. Now, if you have more than one column that you're querying the same combination of columns, it may make sense to have a composite index. If you're not happy with the performance of separate indices on two different columns, a composite index will work well in that context. And as I already said, if both of the columns have bitmap indices, Iris's SQL optimizer will take care of it. You don't need to define a separate composite index. Healthcare queries can be complex, so often you need to sort of modify the data somewhat, do some runtime calculation. If it's sort of a one-time query, that makes sense. We recognize that may be what you need to do. But watch when you do that. So one is if you're doing anything that changes a data type, that could make the index not work. So this is something that you want to watch for. If there are things that you find you're repeatedly computing, then consider the cost of computing that once. So you compute it, and Sofia will talk about this more later, where you can derive values. If you're going to have repeated requests for the same information, compute that ahead of time once, and then you don't need to be computing that each time a query runs. So dates and timestamps. So Health Insight and UCR's SDA data come with a lot of timestamps. So the time that a lab result came in, the time that a doctor made a diagnosis, for example. In a lot of use cases, though, what you're interested in is the date. Most of the time, you're not interested in whether the lab result came in at 4 a.m. or 8 p.m. It doesn't matter. The date range is usually what matters in most use cases. Not all, but most. So in those cases, you want to use a date data type rather than a timestamp, and this makes the query significantly faster. Dates also reduce the cardinality of the data. So rather than millisecond level values, now you've got dates which there's fewer of them, significantly fewer of them, and then that bitmap indices can work very nicely up to about a 30-year time span. So it won't work well for dates of birth, dates of death, but most other dates, a bitmap index will work very nicely, and so a the combination of a date and a bitmap index works very nicely. So consider if you've got a timestamp type data and you're using it a lot of time based on date queries, this is something that you can do as an optimization. Codes. Okay. So codes are sort of bread and butter in healthcare and healthcare analytics, but we do see people do query descriptions and say, well, I'm looking for diabetes. Okay, look for the word diabetes in the description of the diagnosis. That's generally not going to be very efficient. It's not going to run well at scale. There are use cases where you're looking for a keyword in a description, and if you have those use cases, we have ways to do that with iFind and vector search. Vector search, there's other sessions that talk about them. That's beyond the scope of this talk, so I won't get into it. But text searches I'll just say, requires some thought. If you have codes, really work on using the codes. Don't try to search the description of the code for something. Data quality, that sort of goes with codes. You collate data from different sources. You have lots of different coding systems. You have coding systems, ICD-9, ICD-10, SNOMED, et cetera, which can increase the variety of your codes. And that's okay to a point. And if you need that, that's okay. But if you can normalize your codes, if you can pick one terminology system that you'd like to use, let's say ICD-10, and you can normalize your codes to that, then you're going to reduce the number of, the variation in your column, and that again will speed up your queries. So think about doing that. If you've got codes that are all over the place, we do provide tools to normalize codes. Take advantage of those, try to normalize and get your codes. In addition to making the job of the analyst easier, where there's one code system that they need to think about, it makes the query performance better also. Tune table, some of you may be familiar with this. This is an Iris concept where essentially, periodically, Iris needs to capture information about the table before it can sort of optimally run queries. Health Insight runs tune table periodically, roughly an order of magnitude growth in data, but this can be suboptimal. That in future releases, we're going to run it more frequently, and our Iris, the data platform, is also working on automating this and improving this. There are other sessions that talk about this, but for now, if you've had a period of growth, in your data volume, you've brought in data from a new facility, you've brought in new types of data, claims data perhaps. If you've had growth in data, then I would say make sure you run tune table at the end of that so that your table statistics are up to date. Iris chooses an optimal query plan to run the query. Okay, that was a lot of information. As I said, Iris gives you a lot of ways to organize, store data, but that comes with some work that you need to do to optimize query performance. Now, the good news here is that we've done a lot of the hard work for you. We've looked at the query patterns that I talked about, working with a lot of customers, and we've baked this into the latest version of Health Insight. So in typical healthcare queries that we see, you can expect by, not a guarantee because your data might be different, but in most typical cases, you can expect that if you upgrade to the latest version of Health Insight, your query performance should be 2 to 6 times better. So even if you don't take away anything from all the rest of the optimization guidelines that I gave you, this is the one thing I want you to remember. Upgrade to the latest version of Health Insight, and you're going to get significantly better query performance. You don't need to think about it. We've done most of the heavy lifting for you. With that, let me turn it over to Sofia to give you some more advice on
Sure.
optimization.
Thank you, Kandy. So we just talked about all the ways that Health Insight helps you speed up your queries for common use cases, but it opens the question of how much do you have to do to speed them up if you have uncommon use cases or maybe uncommon data. And the answer is not much, really. It's quite simple. So I will just run through a few common scenarios that you might run into. So for example, let's say you need to use a field in your query, but we do not index it out of the box. So what do? You add a custom index on it, which is a single line in your custom namespace. You just add it, you define it however you want, you build it, and you're good to go. The only thing that we ask you to keep in mind is adding a Z prefix to the name of your custom index. We do that because we do not want to run into a situation where, say, 2 releases later, we add an index that just happens to be named exactly like the index you added. So this helps us avoid that situation. This is the only caveat, really, that you need to know. A more interesting use case is pre-computed values. So let's say you want to use patient's age at the time of encounter in your query. Or maybe you want to take a timestamp and cast it as a date. Well, depending on the time of computation you want to do, the index that was built on the original values of the column just may not be useful, and it will slow your query down. So what you will want to do instead is create a computed field that will perform that computation for you at time of ingestion. And by the time you want to run your query, it will already be ready for you to run. So this is 2 lines in your custom namespace, one to define the computed field and the other to define an index on it. Of course, you will need to build that index, but that's no rocket science. And another thing, probably the most useful use case, is a subtype of pre-computed values, which is, let's say you want to, if you want to tell that a certain record is part of a value set. Let's say you want to find all the patients with communicable diseases, right? So instead of stringing together a long query where you say where diagnosis code is A or diagnosis code is B, what you want to do is prepare a value set and load it up into the value set table that we provide out of the box. And then, once again, you will want to define a computed field and a computation method for it that will, once again, at ingestion time, go and look. It will take the diagnosis code and it will check it against the value set and give you the simple answer, yes or no. So by the time you run the query on your data, it will be very fast because there will be no additional computation involved. And that's all I have for you. And we will open. No, that's not all I have for you, actually. Kandy has more.
Well, I think, so very quick takeaways. I'll leave that on here. We've got about a minute here for questions, so I'll take questions while you can read the takeaways there. As I said, the big one for me is upgrade to the latest Health Insight. We've done the heavy lifting for you. But questions, we've got about a minute before we wrap up. Yeah.
So the question was, let me repeat it. The question is, do we recompute the computed field if the original data changes? The answer is yes. You can define when it will be recomputed. If oh, the compute logic has changed.
So in the example of the diagnosis code, I had this 10 codes which I received, say like these are all by the words of the disease. They're much part of my now I add this new code, and now I have to compute it for like it's very bad. I can do that.
So it sounds like your value
set
set
changed, yeah.
gets updated. So I feel like the answer to your question, it depends on how you formed your original value set, right? Where you, who defined it? If it was you.
The stupid combination that the three It doesn't matter. It's changing.
Yeah, it's changing. Yeah.
What do I?
How do you recompute the? How do you force recomputation? So not ready to force recomputation of that column?
it sounds like yes, you will need to recompute the whole thing just to make sure. But
Yeah, I think you'll need to trigger a compute on each of those. You can do either sort of a simple update on each row or just on that column even.
Is there for that or for each and every patient going week out update?
No, you will just need to kind of bulk recompute it for the entire column. You just do it once. It recomputes the entire column for all the patients for every record. But it's a good question. Can we optimize that?
It does happen quite a lot.
Yep.
Requirements, they score definitions, your base different. 2 days later, 2 months later, they're doing definition, they score definition changes for like,
That's a very good point. Thank you.
Yeah, we'll look to further optimize that, make that easy, I guess. Maybe give you a utility to go do it for you. Other questions? Okay, thanks. We'll be out in the hallways if you have any more questions. Thank you.